So we're going to now continue on with naming binaries. Metal to non-metal. But now we're going to go the opposite way. We're going to go from formula to name. And I'm going to switch between Appendix B and doing an example. So remember, you never write anything on your appendices, right? You never write anything on your appendices. So let's start with, oh, I don't know. How about, yeah, why not? Aluminum's always a good one. AlSe. Now you can use Appendix A and B on your quizzes from now on. It's just that first quiz you can't use anything on. But for the rest of these quizzes, you can use your appendices. So this flow chart helps organize all of the different naming rules. So there are 6 categories. 6 different categories. We are just learning the first category right now. Metal bonded to a non-metal. So again, you write this in your notebook. I'm going to write it on the overhead so that our friends in Outer Mongolia can see what we're doing. Except we're doing selenium. Okay, so start with your flow chart at the top. Does this start with the letter H? No. No. How many capital letters do we have here? 2, A and S. 2 capital letters, Brett, means that it's a binary. Why? Because there's only 2 elements. So worksheet number 1 is just 2 elements bonded together to form a compound. Later on, we'll do ternaries. We have 3 or 4 or 5 elements bonded together. Question, Rachel?
Is it AL2 or is it AL3?
I got that backwards. Thank you so much. It should be this. Okay, so 2 capital letters is the first element a metal. Yes. Now how do you know if an element's a metal or not? That is why it was so important for us to memorize this periodic table at the beginning. Because everything to the left of the staircase is a metal. Everything to the right is a non-metal. Now when it comes for naming purposes, we throw the metalloids in with the non-metals, okay? So basically, if you're to the left of the staircase, you're a metal, and otherwise the rest of them get lumped together. So the first element is aluminum, a metal. Yes, it is. Name the metal ion. So what is the name of Al? Aluminum. Then it says, watch out for those Roman numeral ones. In other words, ones that have more than 1 charge. Can aluminum be more than 1 charge? No. Now this gives you some examples. It doesn't give you all of them. Now Appendix A gives you all of them. But there are other ones that have multiple charges like, let's see, iron, they don't have antimony on there, they don't have cobalt on there. Name the root of the nonmetal ion. So what is the name of Se? Selenium. Step 3, change the nonmetal ending to IDE. So step 3 over here says change the nonmetal ending to IDE. So we change the selenium to selenide. So aluminum selenide. Question? Okay, let's do 2 more examples. Let's do how about oh yeah, let's do that. Copper 1 sulfide. Yes, you guys are right. Alrighty. Mistake. So let's then do a different one. How about we do, well, okay. Okay, we'll do this one. SnCl2. So again, does it start with the letter H?
No.
No. How many capital letters? 2. Is the first element a metal?
Yes.
Yes, it is. Name the metal ion. So what is the name of Sn? Tin. Watch for those with Roman numerals. Can tin have more than one charge? Yes, it can. Tin can be a +2 or it can be a +4. So how do I know? Basically what you're doing now is you're reversing the crisscross method. So yesterday we learned how to go from name to formula. We said write the charges in crisscross. Now we're going to basically go backwards. And if take that 2, it goes up there. The 1 goes back up there. So it's tin 2. So you just reverse the numbers. Tin 2, name the Cl. What's the name of Cl?
Fluoride.
Chlorine. Change the ending to IDE. So it becomes tin 2 chloride. Okay, 2 more, and then I'll give you some work time. HgCl2. So, does the formula start with hydrogen? No. Okay? That's an H, but that's not hydrogen, that's mercury. How many capital letters? 2. Is the first element a metal?
No.
Yes.
Oh,
Remember, how do we know it's a metal? Left of the staircase. So mercury is to the left of the staircase. Name the metal ion. Mercury. Watch out for the ones with Roman numerals. So, what charge does mercury have? Because it's going to be either a +1 or a +2. So if it's got more than one charge, Sam, you have to reverse it. Okay? So the 2 goes up there. 1 goes there. It's mercury 2 chloride. +2, you reverse the numbers. Now what if it is this formula? So mercury 1 is the one that kind of messes people up, Mark. Okay, you really can't switch the numbers. You really kind of have to remember that if it's 2 and 2, it's 2 and 2, you write, then it's mercury 1. Because individually, each mercury has a 1 plus charge, but the overall charge is a plus 2. But individually, it's a plus 1. So individually, each mercury has a plus 1 charge, the chlorine has a minus 1 charge, but because it's a diatomic ion, it's got to be 2 there, and so therefore we end up with 2 of them there. So any questions on, yep,
So where are the ones coming from with the,
here?
yeah,
Well, yesterday when I was writing on the board, let me just grab a different overhead. Maybe I'll just draw it. Remember that mercury 1 is automatically diatomic. Mercury 1 is diatomic. So you've got 2 mercury atoms. So I can't just add 1 chlorine. Because if I do that, it's not neutral. Plus 1, minus 1 still gives me an overall charge of plus 1. I need 2 chlorines to balance it out. Now the overall charge is 0. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. So mercury 1 is the tricky one because you can't just switch the numbers and put the 2 up there and the 2 up there. You just really have to remember that when you see 2 and 2, that it's mercury 1. Because, like I said yesterday, mercury must, when you've got mercury 1, it must be diatomic. And so I always say you balance with the overall charge, not the 1 plus charge, but the overall charge. And so then you end up with this. You erase the number 1, you erase your charges, and that's how you get Hg2Cl. Is there another question? Then there's one last thing I want to point out to you when it comes to naming binaries, and it's an old way of doing it, but you will still encounter it every once in a while. If you have things that have, so when you are using Roman numerals, that's the IUPAC method. Okay, that's the official method of naming metals to nonmetals. But there is an older system that still a significant number of chemists use. And so you need to be aware of this. It's based off of the Latin names. And basically how it works is for elements that have multiple charges or multivalence, you change the ending to ic for the higher charge. And you change the ending to OUS for the lower charge. So for the higher charge, you change the ending to ic. For the lower charge, you change the ending to us. For example, let's name these two. Now, when you use this old system, the stock system, you need to use the Latin names for these elements. So, what is the Latin name of copper? Cuprum. Now, this is the +1 copper, because if you work backwards, no, I'm wrong, that's the +2, just kidding, just kidding. So there's a -1 there, 2 times -1 is -2, the charge on that copper has to be a +2. Down here, the charge on the copper is going to be a +1. So if it has the higher charge, you're going to change the ending to ic. So it becomes cupric chloride. If it's got the lower charge, then you change it to OUS. Instead of cuprum, it becomes cuprous chloride. So ic means the higher charge, us means the lower charge. But you gotta know the Latin name for it. Yeah, Alex.
Higher or lower compared to what?
So copper can only be 2 possible charges, +2 or +1. The higher charge gets the ic. The lower charge gets the us.
What if it just has one charge?
Then you don't use it. You just name it. So sodium can only have 1 charge, +1, so it's sodium chloride. This is only for when there are multiple charges or multivalents. Okay? Yep.
Sorry. How do we know when an element has multiple charges?
Either you memorize them like me, or you look on Appendix A. Because on Appendix A, it shows all the ones that have multiple charges.
Okay.
So let's just do one more example of this for funsies.
Mercury.
No. Because I cannot pronounce the Latin name of mercury.
What
Right.
is it?
It's like hydrogenum or something like that.
Hydrogenum?
No, I don't think so. It's spelled in your packet, but I have a hard time pronouncing it. Suppose you had, oh, let's do this. Let's not do chlorine. Do something different. So this one, the tin is going to be a +4. Here the tin is going to be a +2. Tin can be a +4 or tin can be a +2. So if it's the +4, you got to change it to ic. That's the higher charge. If it's the lower charge, you got to change it to us. But again, it requires you to know the Latin name of tin. You know it?
No, but
Oh.
I was gonna say that the plus should be after the numbers.
Technically speaking, it should be.
Do we have to memorize the Latin names?
No.
Or is-
On the
You will
bottom.
only be tested on the official IUPAC system. I want you to be aware of this system because there are still a number of chemists who use it. When I order chemicals, I order cupric chloride. They don't say copper 1 chloride, or no, that's copper 2 chloride. So in the catalog, it actually says cupric chloride. So, or if you're working in a lab, you might go to the shelf and grab a dusty bottle, and that dusty bottle might say cuprous chloride. So I want you to just be aware of it, that it's out there. But I'm not going to test you on this method. But you should be aware of it. So what's the Latin word for tin? Yeah, stannum. So if it's the higher charge, it becomes ic. So stannum becomes stannic. So that'd be stannic oxide. If it's the lower option, then you would change it to us. So it'd be stannus.
When we write what their names are they supposed to be lowercase or capitalized? Or does it not matter?
The first one's supposed to be capitalized, the second one is not.
Okay.
Yeah, you can tell I'm not exactly a stickler on it. Is there another question?
SN, it's got the plus and all
On the
Well,
bottom.
not really.
And you did it on the overhead too.
I think I'm gonna go crazy. Okay, any other questions? Yes, sir.
How do we name nonmetals?
Oh, we haven't gotten there yet. So this is only for metal to non-metal. And then we'll have a whole nother set of rules for non-metals bonded to non-metals. So, one topic, drill, quiz. One topic, drill, quiz, and they'll start to build, and we'll start mixing them more and more.
We're gonna have a huge test on this.
At the end, yes.